I'm with Henrik Leerberg, Product Line Director for Structureware for Data Centers at Schneider Electric. Henrik, there's a lot of discussion about energy savings by maybe increasing the temperatures inside the data center. Why aren't people able to do that reliably manually?
Yeah, so what we have seen with many customers is that they have people walking up to every individual crack unit and adjust the set points manually in kind of a feel kind of attitude, right? Mm-hmm. We feel it's warm, we feel it's cold, and so on. But the problem with that, and with our latest kind of developments in this area, Cooling Optimize, is that it's really, really hard to do manually because it's hard to understand the relationships between a cooling unit and the racks that it's supposed to be cooling. Mm-hmm. So we have introduced something that we call influence map for cooling, which means that we understand exactly how every single crack unit is influencing each individual rack on the data center floor. That means that when we are automatically adjusting the crack units to give the necessary air or cold air to the data center, we know exactly which crack unit to turn up or down in order to be most efficiently cooling down that spot in the data center that is maybe not close to the crack unit, but maybe be remotely located. So that is the difficult piece about airflow, because it's so hard to predict where the airflow actually goes and where it cools down and heats up the data center.
When you've shown influence maps to your customers, have they been surprised at how airflow is actually delivered, or where airflow is kind of sourced for a rack which might be somewhere else?
What we can demonstrate in the software and the customers can see in the software is they can see what happens if I turn on this crack unit here. Then it becomes hotter over there. It doesn't become colder, right? So, and that's a big surprise to many of our customers, that turning on a crack unit can actually make it hotter in one area and colder in another. And if you look at that, you will be completely surprised how your cooling environment is actually performing, because that is not something you intuitively would actually understand.
So, using by automating procedures through capacity optimization and using influence maps, customers can really start to kind of harness some energy savings without really threatening the redundancy of their data centers or the ongoing operations of their data centers.
Yeah, exactly. We have had customers already walking into the data center now being automatically controlled by our Cooling Optimize and say, I think it's too hot in here, but it's actually not too hot. Maybe it feels hotter because it was overcooled before, but it's right at the right temperature right now.
So Henrik, how do you go about building an influence map?
So the influence map is definitely not done manually because you cannot do it. So we do it as we install the software. The first 6 to 12 hours, we actually have the software learn the system. And it learns the system and the influence map by turning on and off each and individual crack units and see how that influences the temperatures in the room at different points, or all points actually. And by having that map, it's really the baseline for our automation afterwards. But that is only kind of the first day or day one of this installation, because as we all know, the data center changes, you put in more servers, or maybe you use more compute and the picture will change. But we have this as a baseline, and then the next week there will be another baseline, because we do that all the time. But initially we do it kind of run through the entire system, shutting off and turning on the different crack units.
So it's always looking to optimize?
Yes.